Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. And for this one, we will focus on section 2.6, which is about addition of Cartesian vectors. So we have covered before what is the difference between scalar and vector. We have dealt with before how to get resultant of vectors, how to get how to resolve vectors, and now is basically how to add vectors, different vectors basically. Right, so this is from the slide with chapter 2.6. Right, so basically the first step is the ability to get any vector into Cartesian vector form expression in terms of I, j, k. Right, that would require you to deal with the trigonometry, and hopefully you have done the trigonometry part. And if you found any problem, please refer back to the trigonometry video. If it doesn't explain anything that you need, please make sure that I know so that I can cater for that. Alright, so let's go for this example. Right, I think we have touched before in the video, in the previous video, that when you have expressed already, like for example a equal to ax and a what is it? If we already expressed a to ax I plus ay j plus az k, and b, for example, is bx I plus dy j plus bz k. Then if we have c equal to a plus b, it's simply just addition of x component, y component, z component, right? So whatever here that you add, it becomes something here I, whatever you add here becomes something here j, whatever you add here becomes something k. Right, so that's that far we have covered before, right? And I believe in the slide what we will cover after this is some example where we will deal with actually combination of what we have covered before involving the trigonometry and this concept. Right, so there's some important notes there. Sometimes 3D vector information is given in magnitude and coordinate direction angle, or sometimes it is given by magnitude and projection angle. So now these two type of angle that we, or direction that we can or have covered, right? What it means by magnitude and coordinate direction angle is basically if you have something here, let's say E, and you have x, y, z, and when you have alpha, beta, and gamma, so that alpha, beta, gamma there is what we say coordinate direction angle. Right, make sure you are familiar also with the terms used. Right, for example, if the question asks, give the final answer in Cartesian in coordinate direction angle, then you know what it means: alpha, beta, and gamma. Right, so that's one way that the direction can be given, and we have covered how to get this one. Right, you know, the cos equation, etc. that we have covered in the previous video. And for projection angle is when you have for example something like this, right? This is where, because you will have whatever angle here, theta 1 for example, and theta 2 here, right? So that there here, this is what we call projection angle, right? Because this is projected to this plane and this is projected to x and y. So make sure you understand how to deal with this and also this, because the angle can be given, the information can be given by both, and sometimes in the same question you have this and this, right? Alright, hopefully we'll have some example here. Alright, example, please refer to your slides. So this is an example, because perhaps I cannot redraw the actual diagram here, right? Especially in 3D, it will be quite difficult for me to redraw everything. Okay, here we have basically, if you see the slide, you have the hook and then you have two forces, right? I'll try my best to redraw so that we can actually relate to what story is all about. Now for F1, hopefully you can understand the way it is being drawn. So basically we'll have the line like this. Wait, it is drawn not in that angle. I try to draw in accordance to the diagram itself. So it has some angle like this, right? So maybe this one. Oh, something like this. X, Y, Z. Okay. Is it still in the frame? Yep, X, Y, Z. Okay. Now for F1, it is given something like this, right? Where you have the force F1 there equal to 500 Newton. This is the magnitude, of course. And we have the angle given there in terms of the triangle 3, 4, 5. Okay, something like that. Of course, you can refer to the actual picture in the slide. And here you have something like this, where this is F2 equal to 800 Newton, right? And then you have this one where this was 30 degrees, and then this one is 45 degrees, right? So there are two forces here, F1 and F2, and hopefully you can appreciate where it is. Now the way this is drawn, right? The actual drawing is in the slide, again refer to that. But when you have something like this, it means that this force is on this plane, this Z, Y or YZ plane, right? So it's on that plane. When it is on that plane, it means that it doesn't have X component. While this one, it does have X, Y, Z component, because X component is here, Y component is here, and Z component it goes down, right? With this angle projected, right? Meaning this 45 degrees is projected downwards 45 degrees, and this 30 degrees is from X 30 degrees and then go down 45 degrees. This is what I mean. From X 30 degrees and then go down 45 degrees, right? From X and then go down there, right? So hopefully you can imagine. That's the first thing. If you cannot even imagine what's going on, then it will be difficult. So please try to imagine things, and hopefully you can imagine this. Alright, so the thing is how to get the Cartesian vector of this both, right? Positive force. Now for F1, what's the X component? This should be without any, wait, is it still in the frame? Yes. Should not take that much time because there's no X component there. So 0I. What about the Y component? This is it. So hopefully by now you already know how to use this triangle. So it's positive Y. So positive 500 times 4 over 5 J. Okay, it's already almost at the end of the screen, is it? And for K is plus 500 3 over 5 K. Is it still in the screen? Yes. Okay, right. So that's this one. What about F2? F2 is X component is this one, right? So hopefully you have referred to the video on the trigonometry, and I'll just straight away go to write this one, right? Okay, so if you write straight away, so it will be 800 cos 45 cos 30 I positive, right? And then positive here is plus 800 cos 45 degrees, and then sine 50 degrees J, and then minus, obviously because going down, 800 sine 45 degrees K. Alright, I have to write in that layer because it's not enough space there. Okay, so now of course for those who have done some exercises, they can do this straight away, right? But for those who still need to do step by step, okay, hopefully I'll just refresh what is going on. So if you consider the two triangle, right? The first triangle is this one, this triangle going down here, right? That triangle here, that triangle going down. So if you look from this side, it will look something like this, right? Where this one is Fz, obviously, F to Z. This one is the 800 Newton, and this one, let's call it F prime here, from here, right? And then for this triangle here, I put it here. If you look from top, it will be something like this, right? Where this one is F to X, this one is F to Y, and this one is obviously F prime there, that we have labeled this F prime, right? So from here, F to Z becomes, okay, what is the angle? This one is 45 degrees, this one is 30 degrees here, this one is looking from top, right? So from here you can see that this F to Z is 800 sine 45 degrees. That is F to Z, right? The Z component of 800 sine 45. And obviously, if you go to put in the Cartesian vector form, it's negative because it's go down. Also, you have 800 sine 45 degrees. It's the same. F prime here is 800 cos 45 degrees. Alright, what about this one? So, based on this, F to X is basically F prime cos 30 degrees. And this one is F prime sine 30 degrees. Right? Straight away. But of course, F prime we already know here. F prime is 800 cos 45 degrees. Right, so just replace this F prime into this F prime, you will get 800 cos 45 degrees and then cos 30 degrees, which is the same as this one, right? 800 cos 45 cos 30. This one, you plug in F prime here, you will get 800 cos 45 degrees sine 30 degrees, which is exactly the same here, 800 cos 45 sine 30 degrees. So this is step by step that if after watching even the trigonometry video and you haven't done enough exercises, you should have enough exercises. But if you haven't, this is a reminder for you, so that when you have done enough of these two triangles, to get this one become something that you can do straight away. Right? It's not compulsory to do straight away. It's if you feel safer to do the two triangle, do it. But it will not take that much time. It will just take like 15 seconds, 20 seconds, 15 seconds, 20 seconds. It's less than a minute. You should be able to get this one. Right? This one. Alright. So as you can see here, we haven't done actually, okay, the question is, what is the resultant force in Cartesian vector form? Right? So the end question is, what is the resultant force in terms of Cartesian vector form, in terms of I, J, K? That is the question. Right? So you have to understand the question first, because this question here does not even ask for the magnitude, or angle, right? So it's just what is the resultant in terms of Cartesian vector form. As long as you can get this one, this question is answered. Right, so the first step is always get the Cartesian vector form of each forces. Once you get this one, you can add to get the resultant. That's quite straightforward. So as you can see, all of this trigonometry is just to establish what is this force, each of these. And then we can add them together. If you get any mistake here, or both, then obviously whatever you calculate later will be a mistake, will be wrong. So make sure all this trigonometry, do not delay to resolve if you are either you don't understand or you are too slow in doing it, right? Make sure you have enough exercise. Yep, you just try some question and it will become easy for you, inshallah. Alright, so what is the resultant? Resultant is just addition of these two, right? So basically for x component it is 0 plus this component here, you get whatever that is I, right? I'm just showing the step because the value I don't have the calculator and I don't want to spend too much time doing the calculator in the video, using the calculator in this video, right? So you know what's going on. You add these two, you get this one, and then plus you add this and this, you get the y component, and you get this plus this one, you get z component. Of course, this one is minus 800, this one is 500 plus. So depending on what is the value here, you might get positive or negative depending on that value. And in this slide here, if you see the value, you'll get positive. No, sorry, I haven't. You get negative, right? So you get 489.9 I plus 282.8 J minus 565.7 K. So whatever the value there is based on whatever the value up here, right? So hopefully you understand what's going on and how to deal with this, right? The question is simple when you are being asked about resultant. It's just the addition of the two forces. Again, as a reminder, this one requires all of this trigonometry. Without this one, even if you understand this concept, this will not be the correct value. This will be the wrong value also, right? And we are still in chapter 2. Make sure you understand that in chapter 4, 5, 6, the question will be longer after this. So if you start with a wrong number here, the whole thing will be affected, right? So again, all of these things, refer to the trigonometry video if you haven't, or if you have and still something that is not clear, please tell me so that we can rectify this in the first week or in the second week. Do not delay more than that. Alright. Oh, sorry, the numbers that I haven't seen the slide until the end. The numbers that I just mentioned just now is actually this one, right? So in the end, it will be 490,683 and minus 266. Alright, so I normally do not refer that much to the slides and just calculate until the end. So I didn't realize I read the wrong slide for the number just now. Alright. Okay, so we go for the next question. This is the level group problem solving there. So I'll just have to erase this one first. Okay, so basically in this question, as you can see, one of the force is given in terms of coordinate direction angle, which is alpha, beta and gamma. Another one is projection angle, right? So if we draw the diagram X, Y, Z, and I'll draw F1 first. So it is with this 25 degrees. 25 degrees, I draw it smaller, right? and then goes down something like this. F1 equal to 250 Newton, where the angle is given as 25 degrees and 35 degrees. Right. So what does this mean? It means that from y, if this is x, y, z, from y it goes 25 degrees before it goes down 35 degrees, right? And then F2 there is Newton. Now, so we have the angle of 120 degrees, 60 degrees, and 45 degrees. Alright, so the question asks what is the magnitude and the coordinate direction angle of the resultant force. So the question says what is the magnitude and coordinate direction angle of the resultant force. Alright, so first understand what is given and what is required. Required is magnitude and coordinate direction angle of resultant force, meaning that we have to find what is the resultant force and then we get the magnitude and the angle, right? So as usual, our calculation will be using the vector analysis. So as long as we can express F1 and F2 in vector form, Cartesian vector form, then you just add to get the magnitude and then you get square root and of course, etc. Right? So again, how to express each of these forms in Cartesian vector form? F1, what's the x component? Alright, so I give you like 10 seconds to think. By now it should be already like automatically you can calculate, right? So x component will be 250 cos 35 degrees sin 35 I. Oops. Right. This one cos 35 sin 35. That's positive. Y component is still positive, so plus 250 cos 35 cos 35 degrees G. You get the Y component. Z component straight will go down, so minus 250 sin 35 degrees K. Still in the frame? Yes. Okay, so that's F1. Again, because I have done many times two triangle, meaning normally you begin at the beginning, normally you do the two triangle, but after you done some that for a while, you can imagine that in your head and straight away got this one, right? I'm showing this because I assume you have already watched those things. It's not compulsory to do in one shot, right? Just do the two triangle and you get this one, right? If you need to. Right? Hopefully, I'm not showing that two triangle. Please try and it should be the same. Okay. So F2. You still remember how to get if you have the Cartesian vector form? Not Cartesian vector form. If you have the coordinate direction angle, hopefully you still remember it's basically cosine, right? Cosine alpha, cosine beta, and cosine gamma. So basically straight away you have 400 cos 120 I plus 400 cos 45 degrees J plus 400 cos 60k. Alright, so it's straightforward like that. You just use, if you have alpha, beta, gamma, you just plug in alpha, beta and gamma, right? You do not need to do something. Now, this is where this is different. When you have projected direction angle, you have to use the triangle. That's number one. Number two, positive or negative depend on its go to the positive side or negative side of the axis. Right? In this case, positive x-axis, positive y-axis, negative z-axis. Right? So you have to apply positive and negative by inspection, by visual. But here, you will see that actually F2 here, it's go to the negative side of x-axis, right? But do not put negative here. Do not. We just put the value here because when you cos 120, the negative sign will come up automatically there, right? So that's the difference. When you have alpha, beta, and gamma, just put the value of the angle. If it's more than 90 degrees, obviously the result of cosine of that angle will become negative, right? So it's automatically there. So when you use alpha, beta, gamma, positive or negative will come automatically by itself, right? Do not put any negative there. It's just positive, positive, positive. The result will be negative something here, positive something here, positive something there, right? So that's the difference, right? So obviously FR, you will see a resultant force there. So how to get the x component? Again, it's just this plus by this one. You get whatever value here, I, and then this plus this plus something here, J, and this one plus something here, K. Again, depend on this value and this value, whether this is positive or negative. It's just based on calculation. Once you get this one, have you actually answered the question? Refer back. What's the question? What is the magnitude and coordinate direction angle? Right? So meaning this is not yet over. So the question one, what is the magnitude? So how to do this? It's simply just square root of this one square plus this one square plus this one square. Right? And what about alpha, beta, and gamma? So it's basically how to do this? Because this one will give you some value here, right? That's the magnitude. So if you still remember, cos alpha is x component divided by the magnitude, right? If you still remember, like cos alpha is ax over a, right? So a is ax is a cos alpha, something like that, right? So meaning that basically here, what is here, which is f x divided by that one, fr, cos alpha is this one, meaning that alpha is cos -1 x over fr. Right. Similarly with beta, so cos beta is this one, which is y over this one, which is fr. So you can calculate beta. So gamma is the same. Cos gamma is this one here is z over this one here and then you can calculate for gamma. With that, you have calculated magnitude and also coordinate direction angle. Just a reminder, when the question asks what is the coordinate direction angle, it will not say what is alpha, beta, gamma. It says just what is angle, coordinate direction angle. You have to understand, that means alpha, beta, and gamma, right? Okay, so actually that is the end of the slides. We actually skip some of the attention quiz, etc. Okay, go through some of the attention quiz or etc. in the slide, and most of it should give you a straight answer. You should already know what's the answer. But if any of those seems kind of confusing, you do not know the answer, please take note. and discuss on the coming class, inshallah. Alright, so we have covered until the end of 2.6. It's already 7 p.m. and next is 2.7, is about position vector and force vector. I think that require significant time, and I don't think we can cram it for this particular recording until Maghrib. So we will see what will happen. For now, we end here. This is the end of section 2.6. Hopefully you have understood this one. It's not difficult. 2.6 is actually just resultant, right? This resultant, and normally you all understand this one. It's just that when you try to do the exercises, you will notice that all of this trigonometry will come into the picture. So normally students struggle with the trigonometry more than to add the force or the vector, right? So please do try, and do try what we have just covered, but do try like 3 or 4 more other problems in the book if you have the book. And with that, I hope, yeah, and I'll try to post some previous exam paper, midterm paper maybe, and if any of that question related to this what we have covered, try to attempt those questions. And if you have any problem, do take note or do comment what is the problem, and hopefully we can rectify any problems in the next class, inshallah. Wallahu alam. So I'll stop here. Wassalamualaikum warahmatullahi wabarakatuh.